one more day, and Thanksgiving break.
Hello.
Hi.
I haven't checked in a while. Did all you guys take your tests?
Yes.
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 Okay. I'll have it graded by this evening. Some of you already have it graded. Ben, you did very good. That was an excellent proof. Excellent proof.
Uh-oh.
In fact, I actually thought Ben had got the proof wrong, and then he chose to prove it a different way than what I did. And when I read it, I was like, oh, yeah, that was good. You could do it that way as well. All right, we ready?
Yep.
Okay.
Yep.
So we'll do an algebra review today. We're going to expose we'll show you some kryptonite today. Those of you that forgot everything about how to factor trinomials, you're going to have problems today. But if you do remember, then this is not a big deal. Today's algebra review is on fractions and reducing the fractions. All right, so it's just basically reduce the fractions. When they say simplify, that also means the same thing, reduce the fraction. So we look at the very easiest of the easy ones. Obviously, I'm not going to insult your intelligence by teaching you how to simplify 8/12ths. Just as a reminder, we're looking for the greatest common factor, the largest number that goes into both the numerator and the denominator. In this case, it's 4. We divide top and bottom by the greatest common factor, and we have simplified that fraction. Now, you can also divide the numerator and denominator by any common factor. You just might have to do it more than once. So I'm sure you're all familiar with, I don't know what goes into 8 and 12, but I know 2 does. So you just simply do it in 2 steps. And for those of you that haven't paid any attention, notice that 2 times 2 in red here, 2 times 2 is 4. And that will always be the case, that if you do it in multiple steps, you can take the numbers that you divide everything by, multiply them together, and you get to the greatest common factor. All right, so no, this is not a class on how to reduce 8/12ths, right? That's the easy ones. It's more of the medium ones, and those are the ones that I'm probably going to have to remind you a few things about. So let's take a look at this one. Yes, this is really called simplifying the fraction or reducing the fraction. So the steps are, we're looking for the largest thing that goes into both the numerator and the denominator, and I would refer that to the coefficients here, 5 and 10. So clearly the coefficients could be divided by 5. Now to handle the variables, there's a couple ways of thinking about it. I always think of it in terms of canceling. In other words, it looks like we have 1b on the top. B squared in expanded form is b times b. And so I think of this as canceling. There is the other method, is that you could use the exponent rule. And the exponent rule says that when you're dividing, you subtract the exponents. So this would be b to the 1 minus 2. I got the 1 from here, the 2 from here. And 1 minus 2 is b to the negative 1. And we know that negative exponents live in the denominator, or live in the opposite of wherever they're at. So we can move that to the bottom and turn the exponent positive, and we would get 1 over b to the first. Sounds really complicated. That is the rule. I always choose to look at it as canceling. I just think it's an easier way of doing it. There's 1 on the top, there's 2 on the bottom. 1 would cancel off, be left with 1 on the bottom. For me, I think that's just a quicker way than thinking out the division rule. C doesn't cancel with anything, so therefore, once you're done with everything, you're still left with a C on the top, a B on the bottom, and 1 times C is C, so we can get rid of that 1, and there you go. Hopefully that is, well, I know that's not new, because I taught it to you last year, except for Hannah and a few rest of you. Wait, Hannah's not here in class. She's doing it online. That's right. Never mind. We can make it very complicated here. Notice once again, the process is still the same. We think of these two numbers, 12 and 8. You can think of it as negative 12 and positive 8 if you'd like, but 12 and 8. What goes into 12 and 8? A 4. So if I divide the top and bottom by 4, just the coefficients, we would get, let's see, we get what? Negative 3 over 2. And then we handle each one of the variables secondly. let's see, x squared and x squared, well, those would cancel each other out. Oop, I already wrote the answer. Those would cancel each other out. And then we have 3 y's on the top, 2 on the bottom. We'd be left with 1 y on the top, and, well, there's your answer. Questions on anything I showed you so far? Pretty basic, right? So those are kind of more like the medium ones. Not much to think about there. It's the more challenging ones that I want to direct your attention to. And we can spend as much time as we need to refresh your memory on how to factor. So these are the ones right here we'll spend the most of the time on. Okay. When we have a fraction where we have polynomials in the numerator and or the denominator, then the step or the technique is that we simplify or we factor the numerator, we factor the denominator and see if anything cancels. So the basic technique is we factor. Now, what does factoring mean? I always think of factoring in the terms of division. I'm looking at the numerator here. What's the largest thing that you can divide out of the numerator? Let's see, 9a and 12. The largest thing that would come out is a 3. Now, yes, I had to make this one coincide with this number here, but that is a coincidence that 3 can come out of the numerator. But we're looking at the numerator all by itself. We're not paying any attention to this 3 right here, but we can divide a 3 out of the top. And like I said, I think about this as division. 9a divided by 3 would be 3a. 12 divided by 3 would be 4. So I factor that out, and now we can see that the 3's would cancel, and we would be left with 3a plus 4. Okay, now we did that last year, and hopefully that technique, that skill has not left you. Questions so far? All right, let's look at a more complicated one. So here's one where we can simplify through factoring the numerator and the denominator one at a time, and it doesn't matter which one you do first. If we factor the numerator, Anna, what would we get?
3 times 3a plus 4.
And Allie, if we did it to the denominator, is there anything that can come out of 3a and a 4?
1.
Just a 1, and we never have to divide by a 1. All right, so that's what it factors into, and I just want you to notice that we got a 3a plus 4 on the top through multiplication, and a 3a plus 4 in the bottom, in the denominator. So those two would cancel, and by the way, this whole ugly fraction here is just the number 3. That's kind of crazy to think about it. This whole fraction right here is just the number 3 after you reduce the fraction. Okay? It's like thinking about, I don't know, 120 over 40. That big honking fraction is just the number 3. All right, so one more time. McKinley, numerator, what can come out of the top?
4?
Yeah, and how about a 4a? Notice both terms have an a in it.
Yeah,
So
4a.
4a. So if we pull a 4a out for me, once again, I think about this as division. And I'll just show you what my mind does. If I divide a 4a out of this, well, the 4 and the a would go away, and you'd be left with b. If I divide a 4a out of this, the a would go away, and it would be 12 divided by 4. So if I divide all of that, out of the first one, I lose the 4 and the a, and I'm left with b. And on the second one, when I divide 4a from it, I get rid of the a, and 12 divided by 4 is 3. That's kind of my thought process. And I already showed you the next step. Since there's a 4a on the top and the 4a on the bottom, they can cancel. You're left with b plus 3. Now, I generally will run into some students who think this, x plus 4 plus or minus, it doesn't matter, y over x plus 4. Ben, are you here? Speak, Ben.
It's here.
Yeah, I see him. Ben.
Yeah.
All right. So I want you to look at this fraction right here. X plus
Okay.
4 plus y over x plus 4. Can we cancel out the x plus 4s?
Well, you can, but you shouldn't.
All right. Yes.
Because if you cancel out the x's 4s, you get y over 0, which you cannot do.
Right. So the answer to that question is no. And the reason why you can do it to this one is because this is attached to the b plus 3 through multiplication, right?
Yeah, it's difference
All
between
of these are
multiplication and
attached by
addition.
addition. And so if everything's attached by addition or subtraction, unless it would look something like this. Now, you are allowed to do this. If you had x plus 4 over x plus 4, any number divided by itself is 1. So you could cancel that. But I'll get a lot of students, even if they'll try to trick you and put this in parentheses and even put this in parentheses, and some students will think, well, I can cancel this, right? Well, the reason you can't is because it's still attached by addition between this term, x plus 4, and the y. So if things are attached by addition, you can't cancel. The reason why we can cancel on this one, because these two things are attached through multiplication. So minor point, you'll see this throughout all, whatever your last math course is for cancel. You'll occasionally run into problems where you think you can cancel, you can't. All right, I'm calling those the hard ones, but we have challenging ones. All right, the challenging ones are the ones that have quadratics. So I know for my Algebra 1 class, we literally just had this test, and they're pretty darn good at this right now, but you guys haven't seen this in literally a year. We got to remember how to factor these puppies. Let's take a look at just the denominator first. Let's factor that one first, and then we'll talk about the numerator. All right, remember to factor a trinomial quadratic, 1, 2, 3, trinomial quadratic because it's to the second power. We're looking for numbers that multiply to get to -12 that add to get to there's a hidden one right here, a +1. So remember the technique. I'm looking for numbers multiplied to -12 that add to +1. Go ahead.
-3 and +4.
-3 and a +4, right, would multiply to -12 that would add for 1. If you can't figure this out, then you just go through all the possibilities. 1 times -12 is -12 that adds up to -11. Didn't work. -1 times +12 multiplies -12, it adds up to 11. 2 times negative, you see what I'm doing? I'm just going through all the possibilities until we arrive at the one. None of these add up to +1. The one that adds up to +1 is this one. Okay? So -3, +4. So we're going to rewrite the denominator. You remember this is 2 parentheses, a binomial times a binomial, where these numbers represent what happens after the x. So x minus 3, I wrote 4, oops, x minus 3, x plus 4. You guys remember doing this?
Yeah, and then the top would be x plus, wait.
Yeah, so the top, now this is, they just throw this right at you. They think that you should remember this, but most students won't. This is one of those special case ones. Notice the first one is a perfect square, x squared, and the second one is a perfect square. What we're missing is that middle term right here. But when you're missing the middle term, and the first thing is a perfect square, and the last thing is a perfect square, this always factors into x, and then the square root of this, with one being positive and one being
negative. Makes sense.
And 3 times x is 3x, -3 times x is -3x. Those would add up to 0. That's why you lose this middle term. So I'm going to clear out all my horrible handwriting right here and do it nice and pretty. So both of those would factor to this. Okay. So the top one, it's one of those special case ones. It's called the product of a sum and a difference, and the bottom one is the quadratic.
Then we can cancel x minus 3s.
Yeah. And then notice that because we have multiplication right here on the top and bottom, we are allowed to do some canceling. If there was a plus right here or a minus right here or both, we would not be allowed to do this. But since there's multiplication, we can do canceling. So let's see, x minus 3 on the top, x minus 3 on the bottom, those would cancel out. And you would be left with x plus 3 over x plus 4. All right. They're not going to have one that uses the, at least yet in this chapter, they're not going to have one that uses the quadratic formula. Remember, we've had the quadratic formula. If you wanted to use the quadratic formula, remember that would solve this. We're not interested in solving. We're interested in canceling things. So that's why we're not going to talk about the quadratic formula here, even though it would solve the bottom. Right? And by the way, we don't want to solve the bottom. There's no equals 0 here. All we want to do is factor it. All right. So this one turns into this, and we're done. What I really want to do is just do some quick practice on this. So what I'm going to do is I'm going to go to right here, a nice empty space. And if you give me a moment, I'm going to open up the old algebra book, and I'm just going to throw a couple of these up here so you guys can have some practice, because you guys are out of practice on these. All right, let's see. All right. So I'm going to write a couple of them up here. We're just going to do them real quick. And when you guys have had enough, just say so and we'll stop. All right, so let's see. X squared plus 5x plus 4. Now, I'm not going to do we're not going to do a fraction. All we're doing is just factoring some trinomials. All right, this factors into, I think we're on
X plus 1, X plus 4.
Let's see, two numbers multiply the 4 that add up to 5. That would be a 1 and a 4. 1 times 4 is 4. 1 plus 4 is 5. So this is x plus 1, x plus 5. Okay. All right. Looks like we need to do a more challenging one. How about this? X squared plus 10x plus 24. Don't yell it out, Jack.
Dang it.
All right, McKinley, two numbers multiplied 24 that add up to 10. When you're stuck, then what you do is you think about every possibility. So 24, start with 1. 1 times what is 24?
24.
Does that add up to 10?
No. 14 times 2.
2 times?
14.
How about 2 times 12?
Oh.
Oh, I see what you're saying. Oh, gotcha. Go. Drive on with your bad self. What's the next number?
3 times, what is it? 6? No, not 6. Yes,
Slithering?
6.
3 times slithering? No. How about
Yes.
3 times 8?
That's a number. 4 times 6. That's what the one.
So this one turns into x plus 4.
X plus 6.
There we go. All right. And I wrote a minus sign. Let's do some with minus signs. All right. How about, that's too hard.
Ooh, can I do that one? Whatever the hard one was.
You're not going to see one like this tonight for homework.
Okay.
You asked for it.
I'm doing it in my head.
1 times 72, no luck. 2 times
2 times 36.
And remember, this one's negative, right? So one of these would have to be negative. I don't care. That's
Well, they both have to be negative.
18
they
times
both have
4.
to, exactly.
18 times 4.
What?
Yeah,
How did
18
McKinley get
18 and
that
4.
before you got that? Good job, McKinley.
Because you were just writing out all of the things.
Well, yeah, because what I want to do is make sure that you remember that, trying to do a guess and check sometimes when this number is big is more challenging. If you go in order, then your life is a little bit, it makes the process so you don't skip things. Because typically you'll skip something. All right, very good, McKinley. How did you get that one and not the easy one?
Because I didn't have my math sheet out.
All right.
That's just how McKinley's brain works.
All right. Anna, this one's yours. If you get stuck, you just start with 1. 1 times 26, and it's got to be negative. So negative times a negative is a positive. That doesn't add up to negative 15. Then it's got to be negative 2 and
13.
negative 13. Those two, well, that's a horrible 3. Those two multiplied together are positive 26, and they do add up to negative 15. So x minus 2, x minus 13. All right, let's give one to Allie. How about this one? X squared minus 5x minus 24.
-8 and 3.
So let's see if that works. Minus 8 and a positive 3. That would give me a negative 24. That would give me negative 8x, and that would give me a positive 3x, and those two added together would be negative 5x. Good job. All right, more or less what?
I'm good.
All right, this one is for Jack.
Yeah. That's just going to be 4 and 6. Wait, no, it's not. It's not going to be 4 and 6.
4 times 6 is 24.
Yeah. It's 4 and 2. Well,
Once again, if you get
Hold on.
stuck, you just start with every possibility. 1 and 36, and it's got to be negative. So one's negative, one's positive. That's not 12. Well, how about negative 1 and 36? That doesn't
6
work.
times 6.
All right, 6, but one of them's got to be negative, one's got to be positive.
yeah.
Yeah,
So it's
no
got
one's
to be higher.
And this is the
Because
problem.
that
is
makes 0.
You jump to what you think the answer is, and you kind of skip ones between. So for me, whenever I run a problem, I'm just going to go in order. I'm going to do 1, 2, 3, 4, 5, 6, all the way up to there's no more left. So 2 and
18.
And one of them's got to be negative. All right, well, that gets me to negative 16, closer. And that gets me to positive 16.
So
All right,
it's got to be 3 and 13, right?
so
3 and 12. No.
3 and
No.
12 would be 36, and that gives me a negative 9, and that gives me a positive 9. I didn't get it there. How about 4?
So it's got to be, 4 and 9.
Okay, one's got to be negative.
Nope.
Nope. All right, does 5, does 6? We already did 6, and you're done. So guess what the answer is?
It's not factorable.
This one is UNF, unfactorable. All right. All right, you will not see any that are not factorable tonight for homework, but I just wanted to remind you that not all quadratics are factorable. So today this is going to be on a fraction type thing. And they will all be factorable. But remember, if we're dealing with quadratics that are equal to 0, this is one of the ones where you would absolutely need to use the quadratic formula to get to an answer for this particular one right here, because this one's not factorable. All right, any questions on anything I did?
Nope.
No.
All right, just remember this one right here, the one where you're missing a middle term right here. Remember, this one always factors into x plus whatever the square root of that number is right there. So the square root of, we'll call that b, right? So that factors into that, and then x minus the square root of b. Right? That's what this one will always factor to. As long as this number b is a perfect square. I mean, if this was
Couldn't you also
6, well, I mean, technically it still turns into the square root of 6, but it's just not nice, friendly whole or integer.
Yeah,
integer
couldn't you say
answer.
like x squared plus 0x minus 9, and then just try to figure out what one of those equals 0?
Well, I mean, that's
Well, yeah, 'cause
literally
then it
what
has
we
to be-
are
that has to
doing,
be- yeah.
right? What it is, I mean, that turns into x minus 3, x plus 3, right? So what we're really doing is what number multiplied is negative 9 that added together is 0. So, I mean, it's not that we're changing, but what we try to do is we try to identify the special case ones, and it kind of, I mean, if you're on top of things, it can speed things up. But yeah, you can still say, you know, what number multiplies -9 that adds up to 0? Well, that would be.
But that's only when it's a -9, right?
That's only when it's a -9. It turns out that this one has no solutions. At least in the real number system. So this one has no, and the reason why is because this quadratic is, it looks like this, and its intercept right here is actually 9. I'm sorry, 3. Right?
So then it has no
So it
solution.
never crosses the x-axis here. No, it's 9. I was right the first time. It's shifted above 9. I want to show you that real quick since we got the time. We want to go to decimals. Share. So if you type in x squared plus 9 equals 0, and then we zoom out, where is my, oh, I'm sorry, equals y. There we go. You can see that it is right there at 9. There we go. So this one never crosses the x-axis, so it doesn't have any real solutions. Although you'll find out in Algebra 2, it does have solutions. I'm not actually sure if you do solving quadratics with non-real solutions. You certainly do it in pre-calc, but can't remember if you do it in Algebra 2.
Oh, okay. So you could figure out what that is if you use a quadratic equation. I mean,
well,
using
what happens is you're going to get the, remember the discriminant b squared minus 4ac. When you do this, you actually wind up with b squared minus 4ac. Let's see, x squared plus 0x plus 9. When you do b squared minus 4ac, b is 0, so you get 0 squared minus 4, a is 1, and c is 9. You get -36. And remember, with the
which means you get 6i.
Which means that you get, well, yeah, plus or minus, but we're not going to see this. Clearly, we're not going to see that part until we get to pre-calculus. But we will get introduced to imaginary numbers next year in Algebra 2. All right, that's all I had for today. I did show you the homework, yes or no?
Yeah, you did. 1 through 16, all 18's extra credit.
Right.
I don't think I was there, but yeah.
Okay, it's 1 through 16, all number. You just exited it.
I'm not sure why that happened. One more time.
It's 1 through 16 all, but number 18 is extra credit.
That is correct.
On the slide, it says 1 through 19.
What?
On the, on the page where we clicked on the Zoom
It says
link.
1 through 19?
Yeah.
Okay. Let's do 1 through 19. I know why.
Anna!
No, what I did was I pulled up the non-honors class rather than the honors class. So that's what happened. So,
so that's technically not our actual.
So we're technically not doing 2 points of extra credit.
Well,
for
since
18.
I already threw this up here, I'll give you 2 points of extra credit if you can get 18 right.
Okay, cool.
So 1 through 19, if you can get 18 correct, then I'll give you 2 points of extra credit.
Okay.
I don't think there's any way that they're going to get, at least the majority of the class, they're going to get 18 right. 18 is weird. It's a special case.
Special case or just special?
Special case.
To the paper.
Well, you'll see. You can figure it out if you read the read some of the stuff around it, but it's kind of weird. All right. Any other questions?
Nope.
Algebra reviews are always going to be a quick class. So, all right. I'll have your test graded by 8 p.m. tonight if I haven't already graded your test.
Okay.
All right. Catch you guys later. Oh, remember tomorrow is Friday schedule, assembly at 8 o'clock.
Yes, the assembly.
And our class will be at 1:22. 1:22. All right. Catch you guys later.
All right.